Welcome, everyone, to the podcast Tech Effect. This is a podcast about testing and development insights and debates with industry experts. It will be a completely new podcast that we're launching starting as of today, and we're glad that you actually joined us and tuned in for this. In this first podcast episode, we'll be talking about a very niche software testing service, but one that's in very high demand nowadays, which is audio and video software testing. We will talk about what really is audio and video software quality testing, what goes into it, and why it is necessary, and who really actually needs it and who benefits from it. My name is Adrian. I'm an expert in audio and video testing. I'm leading efforts to ensure the accuracy and consistency of test result data. I'm managing also one of the TestDevLab's biggest audio and video benchmarking projects. Joining for me today in this studio is an experienced software quality assurance specialist who has worked in the industry in IT for over 10 years.
That's correct.
Yeah, for over 10 years. And he's also, if I'm not mistaken, managing some of the biggest projects at TestDevLab. So I'm glad to introduce you today, Deniss. How are you feeling?
I'm feeling pretty good, thank you.
You're feeling pretty good. You don't sound quite well, do you?
Yeah, it's something with my nose, but it'll get better.
Okay. So
how are you feeling?
I'm feeling quite good. I'm really happy that we actually made it to the podcast. The first question from my side would be, how would you describe your 10-year experience working in the quality assurance field?
Well, that's a complex question.
Is it?
Yeah, because it requires going through different thought lines in my head, obviously regarding different projects and different timelines. One of the most responsible projects I had was in a bank.
Okay.
So I was leading testing efforts in one of the biggest mergers in Baltics. That was quite an interesting journey. And actually challenging one as well. Recently, like maybe 2 years ago, we started to deep dive into video and audio testing.
Okay.
At that time, it was totally something new, and I think.
Sorry to interrupt you. Yep. Why did you really switch from, I don't know, functional testing to audio and video testing? What really happened?
I think from the very first day, always try to find the good end or finish line where to kind of cut the rope and start something new.
Was it really hard to switch? Did you grasp things quickly about audio and video testing? Or was it like a whole new world? Like, wow, what is this?
It usually is if you change that drastically. What I was doing in the bank was leading and managing things. It's like almost project or program management regarding all testing activities, all quality assurance activities. And here was completely something different because it required deep dive in technical things. Obviously, if now we will expand this topic, we will witness all the technicalities that come out of that.
What actually is audio and video testing and why it is needed?
Well, if you're trying to be picky, when you say video and audio testing, it can be functional testing, it can be non-functional testing. Video and audio testing is not just about functionally checking that the mute button works, that the virtual background works, that the screen sharing works, but rather looking into those non-functional aspects, which would be impactful to quality of experience of a user from user perspective.
So we're looking at a different perspective, not from the functional side, but from it actually performs from the user experience side, right?
Yeah, and that is I think the interesting part in this, as you said, niche directive, niche area, that we're looking at something deeper, something which is subjective for each user and trying to make it objective. And that's what's challenging about it, and that's what's also in a way fun about it. And yeah, we're basically talking about video and audio quality testing. And quality is a very broad aspect. But in this specific sense, we're looking at like image, video quality, and we're looking at audio, like sound quality, and trying to make sense of how good it can be in the perspective of a user.
Does like audio and video testing is the same that audio video benchmarking?
So benchmarking is one of the aspects in video and audio testing. Like we benchmark specific app to other apps.
Okay, so it's basically cross comparison and see how they perform against each other.
Yeah, that's exactly it.
Nice. If I remember correctly, in the beginning of 2020, I read online that you had only like a TestDevLab, a few setups. How many setups you got now?
It's very dependent on specific current engagements that we have. But I'd say more than 50 at the moment.
Okay, and what really drove the like audio video testing demand or growth?
Well, I think that's kind of obvious. It's for obvious reasons and for not so obvious reasons. But let's look at the obvious reasons, which is people were working more at home, more remotely.
So yeah, let's go back to 2020. It was like everybody was working from offices, right? And then the pandemic came. And that's when companies came to TestDevLab and said, hey, there's a lot of people using the application. We need to test it.
It's kind of a mix of different aspects and factors included in this. We never asked directly what are those factors for a specific client. But if we'd like to look at them that way, yeah. Basically, the demand rose. And not only demand, but also competition, because this market is really booming, and it will continue to grow. And obviously, all the players in the market want to know where they stand, like not only against competition, but as well how well they're doing, progressing, how well their app is developing. So it's not only about competitive benchmarking, but also benchmarking against themselves.
Okay. I saw online that there's like a black box thing. Who actually invented the black box? Like not the black box we think about in functional testing, but like black box in audio video. Like physical black box.
It all started with an actual black room.
Okay.
And
how did this like switch from a black room to like a black box on a table, or where does it stand?
Yeah, we understood that it has to be more mobile, meaning that we're not fixed to a specific place, because you can move a box from one place to another.
Makes sense, yeah.
And with the room, it's you'd have to find another room and paint it black and make sure there's no excess light coming in. Well, one of the reasons that it's black is what I already said. It's because of that light, and that has an effect on whatever we're doing there. And whatever we're doing, in most of the cases, when we have a handheld device, we have to use the camera. And that camera has to film something and capture something. And, we do a capture of a monitor, and we have to make sure the lighting conditions are exactly as they supposed to be.
You mentioned earlier that you need to like replicate real life user scenarios, right? Real life usage, internet speeds and things. And as we know, in many countries in Africa and Middle East, connection speeds are relatively slow, right? So what type of like network impairments are they facing or could face?
Replicating real life.
We know it's quite hard. Yeah, it's not impossible, but we can like do things, right?
Yeah, you can do as close as possible, but obviously you cannot mimic. You can. There are ways of doing it, but those ways are they can be extremely expensive, extremely complex and expensive, and mostly you wouldn't go that far. You wouldn't go those measures in order to get those results. So you go as close as possible and as best and as effective you can do. And in our case, this effectiveness is, well, due to those specialist gears that we have, specialist gear, and we have routers, we have physical routers, we have virtual routers.
So you're saying routers, right? So what we can do on routers is to like limit the bandwidth, right?
Yeah.
We can get variable packet loss.
Yeah, we can do
anything what we want with the delay and
jitter.
Okay, and jitter as well.
Well, packet loss as well.
Well, yeah, packet loss as well. I mentioned that, I think.
Yep.
But in what like real life network situations these type of impairment degradations actually can happen?
Well, the environment applications are vast. Like, let's start with you're in an airport lounge or just in a cafeteria or coffee shop, or
like in a public place.
Yeah, wherever you have public Wi-Fi's. I think most of us who do travel, who has business trips, they have encountered some sort of flaky network environment. I've been there, and a video conferencing app provider to recognize these things and understand the essence of those factors that could impact the behavior of the app and make it work as best as possible.
So let's take one scenario. For example, you said public Wi-Fi hotspots, right? Well, you're in an airport or at a crowded place. And you mentioned devices earlier. So what needs to be exactly in the setup to simulate the network?
Well, it's an actual internet provider, right?
Okay, yeah, makes sense.
So that specific connection goes into the router, and then you have a device which is connected to that router, either wirelessly or with an Ethernet.
And how is like the network simulated on routers? Do they use like special software or something else?
Well, yeah. So first of all, there are physical connections.
Okay.
Or in this case, physical also can be wireless. And obviously, you need the software to run the routing, and also to have interfaces in order to receive all the data and send the data. And on those interfaces, you can have different, throttling capabilities, and routers can have those. If it's a Linux-based router, then you can use traffic control. It's a tool set that you can parameterize, and you can limit on a bandwidth level, on a packet loss level, on anything that can impact sending and receiving packets.
So also data. The queue size and things like that.
Yeah, anything that really works in again, is transmitting the data through packets. It can store those packets for a longer time, for a shorter time. It can hold those for a variable periods of again, time, and have different effects on delays, different effects on overall bandwidth, how much data can flow through. And if you have control over that, essentially, if you have a profile of a specific test environment, like we discussed, like a public Wi-Fi, we could eventually, and what we have done as well in some very specific cases, is record the Wi-Fi traffic of a airport lounge or anywhere, like I said, coffee shop, and we can analyze how much of bandwidth it had throughout a period of time. So we can look at time series data.
Okay.
So data over time, analyze it, and mimic it, right? We can then reproduce it in our controlled environment. So what I'm saying is we can write scripts that can be very static. Let's say you can limit to a 500 kilobit bandwidth with a 5% data packet loss, with a 100 millisecond of RTT additional delay, and that's static. But we also can do a variable thing, right?
Yeah, let's focus on the static ones.
Yeah.
So, for example, we took and put the packet loss on. We limited the bandwidth. Then we're taking the application and starting the testing, right? But we really need to get some kind of metrics. So, what type of metrics there actually are to evaluate the video quality, for example? We also know that there's audio quality, right? And then where there's network metrics, various network metrics, as you said. But let's focus on the video quality right now. What type of metrics does video quality have?
Yeah, like you said, there are quality of service metrics and there are quality of experience metrics. Here we look at quality of experience metrics, and specifically for video, we would need to let's have a difference between two major aspect worlds, should I say. So one aspect world would be image quality. Video consists of a string of images or a sequence of images that are animated and flipped over. And the other world is how well those images are flipping over, right? The fluidity.
The fluidity, which we call actually the frames per second, FPS.
Yeah, that's
fluidity.
That's the measurement interval, right? Second, kind of within a second, so you can measure frame rate.
That's correct.
In a second, so it's FPS.
And for the video quality as well, as I know, we have referenceless quality determination, and we have full reference video quality assessment methods, right? So what does full reference video quality assessment mean?
Yeah, the metric categories that you're mentioning for video is from the first world, which is image quality.
Yeah.
And for image quality, we have, like you mentioned, no reference and full reference. There's also partial reference, but we can, and what we do, we focus on only those two. And one is like this no reference, where you don't, it actually already implies that it doesn't have anything to refer to.
So are you speaking like of Brisk?
Oh yeah, now that you mentioned, you could have dropped the bomb.
Sorry about that. Who doesn't know that Brisk is like image quality evaluator, let's say like that.
Yeah.
And it helps determine the video quality.
I would want to step back and say why we do have two or even those three different categories of evaluating images or image quality. First of all, you would obviously want to use always a full reference because it gives you the best and most precise evaluation, because you always have something to refer to, something to match against, and that gives you the most precise scores. But obviously, if there are those other ways of evaluating, you would definitely have applications where you do want to have those. And those applications or use cases are when you have something that you would want to capture. In this specific video and audio testing use case or kind of test scenarios, you have a handheld device, so you film a screen, and when you do film the screen, there are different factors that impact the basically there are different factors that impact this comparison. So when you receive it on the receiver side,
It can be degraded.
It will be degraded.
It will be.
And on the sender side, you can
see the original
capture, but yeah, what's the original? There's the question, like, what's the reference? Because the reference is the original. And when you do capture it with a camera, that's you can capture, like, the question is where you can record it. So you can record it on the handheld device, but that is not the actual thing that's being captured, right? So you're kind of you're recording it, but it's not the same that is being captured, and that's a bad reference already there. So it's an inherent problem. So you wouldn't have the same alignment of the media that you receive and media that you send, and those differences, even the small ones, wouldn't allow you to do full reference analysis or full reference evaluation. But in those specific cases, you can use Brisk, or you can use something else, which is, so let's, if we look at Brisk, what it is.
Well, Brisk is like pre-trained, like you have 100 people, for example, and they do evaluation of some images, right? So you train a model for the Brisk. Then you can use the model to actually predict the quality of the video.
That's exactly it. Those no reference algorithms try to predict. It's like
so let's say
it's like an AI, it's like machine learning algorithm.
Yeah, referenceless basically is trying to predict, and VMAF and things like that are trying to actually evaluate against the original one.
Yeah, VMAF, SIM, PSNR, some others there are, but we have used to fully implement VMAF, or Netflix developed VMAF set.
Who doesn't know that VMAF is actually quite recent addition to the video quality assessment algorithms, and it's developed by Netflix, so shout out to them.
Yeah, and interestingly, as you said, you can train a no reference algorithm with subjectively evaluated images and frames.
But can you like train VMAF as well? Is there separate models? Because as I know, I recently did things with algorithms. I tried to read about them, and I saw that for the Netflix, if you open up the Git, you can see there's a different type of models. So can you actually train the VMAF?
Well, there are ways to enhance VMAF evaluation. It's not that you have to have a large set of material or anything like that. There are some specific tool sets where VMAF or PSNR SM are kind of out of the box. But to get a best match to your use cases, you definitely need to deep dive and look more into it. Like what we discovered, sometimes an app would change the color schemes or just like colors in the media that's being sent over, so in the images, and that is something that VMAF would recognize and artificially lower the score.
Okay.
And that's a problem, because you would want VMAF to be as objectively subjective as possible. So meaning you would want some score that are closer to the MOS scores, which is mean opinion scores, which you already mentioned, subjective evaluation scores. Yeah. And if it's just the color that sorry for my French, fucks up the scoring, then well, it's something not close to the subjective as possible. So what we've done there, we looked at how we can get the colors back into the same using same levels, using histograms of full color spectrum
Yep.
on an image, so we can match those and get kind of normalized score. Let's call it that.
So what you're saying is that different hardware can have actually different contrast values for the video.
Well, not only hardware, obviously hardware. If you do have different monitors, we also have calibration devices to make those as close as possible to each other and to the expected result. But also the applications themselves do change the image, not only quality, because obviously an app needs to change the quality in order to sustain a good quality of experience for the user, given the specific limitations on the network, right? We know that
they need to find
the pipeline is this much, and this is the amount of data that can flow through, and it's the application job to make sure that this pipeline is enough for a specific set of quality characteristics that it's trying to deliver to the user end.
So if we're talking about a pipeline, there's like, if I'm correct in network, there's like RTP streams, right? And there's an audio and video streams separately. So you need to allocate the correct bandwidth for audio and for the video. If we're talking about the audio, are there like reference-less audio evaluation measures as well? Or how does it work?
Well, so far we have worked only with full reference audio evaluation algorithms. Again, those audio evaluation algorithms are for MOS scores. We would like to understand what's the score prediction for a kind of subjective evaluation. And those are we use Polka. That's one of the licensed algorithms out there.
That's basically like the global standard for benchmarking.
Well, it's kind of an industry standard, one of. And there is also this Google developed open source algorithm, which is Whiskle.
Whiskle.
Yeah.
Whiskey. Yeah, that's the first association, whiskey, isn't it?
Yeah, so it's VISQOL.
Okay. If we're talking about audio, there's like, if we actually put the packet loss as a network condition, we limit the receiver. What can happen to the audio quality?
Well, I would start firstly that audio packets are a lot smaller than video packets, which
makes sense, actually.
Makes sense and is kind of obvious. And that means that the RTP stream for audio, which is the data stream for the audio, would be with a lot smaller throughput. And even if you apply a packet loss, you could lose. Obviously, you could lose either video or audio or any other metadata. And what can happen is that you start losing some bits of information, and those bits of information are either audio or video. In audio, it is a sound, or it can be part of a word. And obviously,
and how can developers like prevent this from happening? Can they even? Are there like methods to, I don't know, send more packets, for example?
Well, packet loss conditions is like a Pandora box.
You never know what happens, right?
Like if you don't want to open it, then that's fine. You would be actually maybe better off with than opening it, because if you open it, you start to really try to solve almost the impossible, because you cannot specifically determine what's the cause of packet loss. Because like if you want to solve a problem, you would need to understand the cause, and that's the problem with packet loss. So sometimes it's better to not open the box.
Okay. I think we have learned a lot from these, I don't know, about 14-minute podcast. And thank you very much, Deniss, for joining us. And thanks everyone who actually listened to the podcast episode that we talked about in general about audio and video testing. I'm quite sure there will be a lot more coming up. Maybe even from the audio and video quality side, we can talk about the setups, how it's actually performed at the TestDevLab. Also, if you enjoyed listening this, feel free to follow our podcast on Spotify or YouTube, where we like publish more episodes with experts from different software quality engineering fields. And if you have any comments or you would like anything to share with us, make sure you subscribe and cover it up in the next episodes. And feel free to reach us on the Instagram page and Facebook or LinkedIn. And yeah, thank you very much, Deniss.
Thank you, Adrians. It was my pleasure.
It was really nice to meet you. Thank you.